So we're starting lesson 8.5 and 8.6 today. We're learning about how to write and graph inequalities. So first thing I want you to copy into your notebooks is an inequality compares two quantities. We already know this from previous math, but it's a helpful fact to know that inequalities are comparing. So they're not solving necessarily, but they are comparing. For our easy warm-up on page 617, I want you to compare using our less than or greater than signs. So for number 1, the score after 2 goals is blank the score after 3 goals. Nathan, what is it?
Greater than.
Do we agree that it's greater than?
No.
No. It is less than. The score after 2 goals is, let's say, 2. The score after 3 goals is 3. The next one, Alinza. The cost to download 10 songs is blank the cost to download 2 songs. She put greater than. Yes, because 10 is greater than 2. What about Jaden for number 3? The outside temperature in summer is blank the outside temperature in winter. It is the greater than sign. Yes. Now, mind you, climate change, Los Angeles, it's not the point. Think about it in the most broadest of terms. Think about what the bad textbook meant. Next, the height of a first grade student is blank the height of a 6th grade student. Carmen.
The height of a 6th grade student is greater.
Perfect. So we get the answer less than. And then lastly, the time it takes to eat lunch is blank the time it takes to brush your teeth. Oswaldo. Perfect. Greater than. Excellent. We already know how to do all of this. So I want you to copy these 4 things into your notebook. The reason I'm having it is because when you're reading a problem, these are the key terms. These are what they mean, and these are key terms that you are going to see. Especially these last 2 are very important because we already know that the less than is fewer than, that the greater than is more than, but you might not know is at most or is at least. Those 2 parts right here, the is at most and is at least, are pretty important because they are new keywords. So we're going to be dealing with inequalities with variables. All we're going to be doing, same exact thing, isolating the variable. We're pretending it's just an equal sign like before. We're going to be isolating our variable, and that's how we find our answer, more or less. That's how we find our set of answers that we're going to graph on our number line. So it's not going to be hard. You guys are going to kick butt at this. I already am super duper confident. So here, if we were solving this, all we do is isolate our variable. Now, this is why I had us show our work last time, because it's not always going to be as simple. So to isolate our variable, we do our plus 3 on each side. We get rid of that, and we get n is greater than 9. We get n is greater than 9. So all we did like last in chapter 6 and in chapter 7, we just showed our work to isolate the variables. The reason we show our work is because it's not always going to be this simple. It's not always going to be this simple. Now, let's see if this is correct. I want you to check this. So I want you to tell me when we're doing this, is this correct? So there's 2 ways we can go about solving it. The first way is isolating our variable, and the second way is just our plug and play. By isolating the variable, this is a plus 7, so we're going to go minus 7 on each side. That goes away. We get a is greater than 8. Does 9 work? Is 9 not greater than 8? I'm very surprised right now, Daniel. 9 is indeed greater than 8. So Elsie pointed out the other way we would do this. So she brought up that we would do our plug and play method. We just plug that in. We get 9 plus 7 greater than 15. 9 plus 7 is 16 greater than 15. So this one is a true sentence. Now, Rocco, what about the next one? Exactly. So Rocco plugged this in. He plugged in the 6. 15 plus 6, we get 21. It's greater than or equal to 22. That is not accurate. No. Hannah, D. Hannah says it's incorrect. She is correct. We get 10 minus 4. That's equal to 6. 6 is less than 6. No. They are equal. So it could be less than or equal to. It could be greater than or equal to. But it has to have that equal to sign. This one is not correct. What about that last one, Liam? Liam says false. What do we think?
Yeah.
We think yeah? Gore says no. A lot of the class. So, raise your hand if you think that Liam is correct, that it is false. So we see a good handful here. Raise your hand if you think it's true. The answer is it's true. It is works. We plug in 7 for G. We get 5 plus 7. That's equal to 12. 12 is greater than or equal to 12. That's why you need to pay attention. So this one is indeed true because it has that equal to portion. Just like on that last page, if we have that equal to sign, they can be equal. If it doesn't have that equal to sign underneath it, then it does not work. That's why our 6 here did not work. In this case, they have to have that line. That line underneath it, I think about it as part of my equals, but that top part becomes like that or becomes like that. So that bottom part is the equals to. So these ones don't work on this side, and these ones do work. Pay attention to that because it's tricky. So here we do. Use one variable equations and inequalities to fill out the graphic organizer. So an instance for that one. In this case, all we do is come up with something. Ready? X plus 3 equals 10. How about this one? X plus 3 is greater than 10. Okay? Same thing, but I changed the sign. How many solutions am I going to have for my equation? When I solve my equation, how many solutions, Daniel? 2 solutions for my equation? No. No, for my equation, I just get 1 solution, and it's equal to 7. Is anything else plus 3 equal to 10? So this is for the equation. So I only have 1 equation that is equal to that. What about with an inequality? What did I get, Rocco? Infinitely many. Because for x plus 3 greater than 10, x can be 8, 9, 10, a million, a trillion, a gazillion. There are infinitely many numbers, but just as such, there are the infinitely many numbers that do not work for it, the other side. So Gloria, what'd you get as the answer to number 1?
9.
She got 9. What do we think?
Yeah, let's go.
No, it is not 9. Because if I plug in 9 for A, I get 18 is less than 17. No! So, what about the next one? Who has the answer? Who has the answer? Nathan.
7.
It is 7. If I plug in 7, 9 plus 7 is 16, which is less than 17. If I plug in 8, I would have gotten 17 is less than 17, and that doesn't make sense. So in this one, our answer is 7. In the next one, b minus 10 is greater than 5. What's the answer that you got, Michelle? 16, yes, because 16 minus 10 is greater than 5. 6 is indeed greater than 5. Excellent work there. What about this one? X minus 5 is less than 5 when x is 15. So, is the given solution, is the given value a solution of the inequality? Is x equals 15 a solution, Anita? No, because 15 minus 5 is 10. 10 is not less than 5. So, the answer is no. Gore, what about the next one? 32 is greater than or equal to 8n when n is 3. Yeah, yes, because when we plug in 3 for n, we get 24 is less than or equal to 32. That works exactly. So that's what we got so far. Raphael, if the bakery sells more than 45 bagels in a day, they make a profit. So we see more than 45, right? Yeah. We don't see more than or equal to. We don't see less than. We see more than 45. To determine what days the bakery made a profit. So what days did the bakery make a profit? They had to sell more than 45 bagels. What days did they make a profit?
The days they made a profit were on Friday and Saturday.
Excellent. They made a profit on Friday and Saturday. Those are the only days that they sold more than 45 bagels. I'm impressed they didn't put one with 45 just to trick you. So for lesson 8.6, your warm-up is page 625. So that is what we are going to do. Go to page 625, and we will work on this afterwards together. Miles, what did you get for number 1?
I circled the numbers from 6 to 15.
Excellent. He circled the numbers from 6 to 15 because those are all more than. Okay, Andrew, what did you get for number 2?
I didn't get it. 5.
So he circled 5 and below because that is the closest number next to 6. 5 people could have rang the bell. 4 people could have rang the bell. What about the next one, Jenna? What did you circle?
1
She said there were less than 10 people in line, so 1 through 9. Excellent. What about Rafi? What did you circle for 4?
more than 6. 7 to 15.
Excellent. 7 to 15. What about 5, Lucy? 1 through 7. There are less than 8, so that's less than 8. And lastly, on number 6, what did you circle, Emerson? 13 to 15. What we have here, because those are the ones that are more. So far, it's pretty easy, right? We're seeing that there are multiple solutions to inequalities. Each of these is an inequality. For example, Jessica spent more than $5 at the arcade. Jessica spent more than 5. So we have to include all numbers bigger than 5. This is how you write an inequality. So if we write this, we see these keywords. You must be over 12 years old to ride the go-karts. So that means that you have to be over, not equal to, not at least. It says over. We don't see that word at least or at greatest. So when we see words like over, less, below, stuff like that, we know that our inequality is just going to be greater than or less than. It's not going to be greater than, less than, or equal to. So we see that right there. I want you to do this in your notebook. A pony is less than 14.2 hands tall, and you must be at least 16 to drive. Write your inequalities. Perfect. So he said 14, as I'm writing with my circles, he wrote 14.2 is greater than X, because the pony is less than 14.2. Gloria, what'd you get for the next one?
I wrote X is greater than or equal to 16.
Excellent, because we see those terms right here. We see at least. That means it's going to have a greater than or equal to. Can you be 16?
No.
Yes, you can be. So we have to have that equal to bit. But you cannot be under 16. It includes 16. We see the key terms, at least. Those were in our notes from just earlier today. We see those key terms, at least. This is the main focus of this lesson. This is how to graph it on a number line. If we get less than or greater than, when we graph it, it's going to be an open dot. If we get less than or equal to or greater than or equal to, it is going to be a closed dot. You'll see what I mean as soon as I show you on the next slide when we look at how to graph inequalities. But what we know is that if you don't have that equal sign, our dot is going to be open. If we do have the greater than or equal, less than or equal, it is going to be closed. So essentially, the open dot includes up to that point, but the closed dot includes that point. So when we saw this, if I had 12 is greater than x, right? X can be 11.99999999. It doesn't have to be a whole number. I get as close as I can, but I do not touch. Actually, it would be below. I get as close as I can, but I do not touch that 12. It is open because that number is not included. However, every number, 11.99999 forever. We are constantly getting closer and closer to 12. We just don't touch 12, which is why it's open. However, when we have a closed dot, that's because we would have 12 is greater than or equal to x. Is 12 included in this?
Yes.
Yes, because 12 is less than or equal to 12. So we include everything, including that 12. So the closed dot indicates that we are including that number, and the open dot indicates we are not. All you need to remember is if you will have signs like this, it'll be open. If you have signs like this, it'll be a closed dot. So, for example, 5.000001 and above. We do not include 5 because 5 is not greater than 5, but we include everything bigger than 5. However, if it said 5 and above, 5 is included. We see that and above, and 5 is included. So we include that 5. Here we get as close to the 5. I know it doesn't look like it because we're not touching that line, but it's an open dot. You need to make it big enough to indicate. Michelle said I said and above for both, which is great. But here's the thing. This 5.000001 was just an example. Essentially, it can be 0000 for all the way up until I end with some one a majillion numbers away. It just does not include that 5 because 5 doesn't fulfill this. 5 is not greater than 5. So it doesn't include the 5, so we don't include it. We leave it as an open dot. So go to page 627. We're going to do A, B, C, D, E, F. This one, you must be older than 13 to play. Older than, Daniel, what does that mean? X is going to be what? Greater than or less than? Greater than 13. How do we know it's not greater than or equal to? Rocco? Older than. We don't see older than or equal to or at least 13. We see older than. So X has to be any number greater than 13. B, Fernando. To use one stamp, your domestic letter must weigh under 3.5 ounces. What'd you get as your equation, as your inequality? 3.5 is less than X. Do we agree? No, we're a little close. So, what is it going to be, Michelle?
I put X is less than 3.5.
Yes, because the letter must weigh under 3.5. This is under less than 3.5. Less than 3.5. C, Romario, you must be over 48 inches tall to ride the roller coaster. What'd you get? X is greater than 48. Perfect, because it says you must be over 48 inches tall. D, what about this? You must be at least 18 years old to vote. Matthew. Y is at least 18. We do see that. So is it going to be greater than, less than, greater than or equal to, less than or equal to? Perfect. Y is going to be greater than or equal to 18 because it includes that 18. We see the words at least. It includes that 18. Can you vote at 18? Yes. So you don't have to be greater than 18. You have to be at least 18. E, if we were to graph this, Melanie, first of all, am I going to have an open dot or a closed dot? What do we think? Closed dot? What do you think, Adriana? we are going to have an open dot because it does not include the equal to sign. And where is our open dot going to be, Melanie? At the 15, exactly. And then which side am I going to color in? Am I going to go color that way or am I going to color this way? Yeah, exactly. So I'm coloring all of these and it just keeps going because A is less than that 15. So it's an open dot because we don't include that 15 and it's the less than. What about this last one, Malia?
It's going to be a closed dot.
It's going to be a closed dot, exactly, because we've got that equal to sign. So it's a closed dot. And which way are we going to draw our number line? Which way are we filling? Are we going to the left or to the right? To the right. Yes, because 8 is greater than or equal to, 9 is greater than or equal to, but 7 is included because 7 is also greater than or equal to 7. 7 is greater than or equal to 7. That's why this is a closed dot. A is less than 15. Does that include 15? No, 15 is not less than 15. So it is that open dot. But is 14.999 less than 15? Yeah, so that's why we include everything except for that dot. So we don't write it, when we do this, we don't write it like this. We don't have an open dot and then just go from the 14 to the 12. Because we have to go all the way until that open dot because all of those numbers, 14 and a half. Is 14 and a half less than 15?
Yes.
Yeah. Is 14 and 9/10 less than 15?
Yes.
Yes. Everything except for 15 below, everything below is less than 15. That's why it's that open dot.
Yes.
So now you're going to do the guided practice, number 1 through 5 on page 628. So Elsie said 90 is less than or equal to x. We are so close. It says no more than 90. So the movie, do we know the length of the movie?
90.
No, we do not know.
Oh, yeah.
But we know it cannot be more than 90. But does that include 90?
No.
Yes, it just cannot be more than. So x is going to be less than or equal to 90. It can be 90. It just cannot be any more. It can be 90. It just can't be any more.
Oh.
Adriana, what about 2?
985 is less than or equal to x.
Yes, 985 is less than or equal to x because it says at least. At least means it could be equal to. The mountain could be 985 feet tall, but it also has to be more. Adriana asked a great question. She said, does the position matter? No. This could be 985 is less than or equal to x. It's the same thing. X is greater than or equal to 985 is the same as 985 is less than or equal to x. As long as you pay attention and that the x is being eaten by our little alligator or not, whatever it is, either side doesn't matter as long as you have it facing the right thing, either the variable or our constant. 3, Gore. Is it going to be an open circle or a closed circle? It's going to be a closed circle. For my number lines, I just put it right in the center because it doesn't matter. And we're going to put our 6 here. Which side are we going to be coloring in? The left side or the right side? Left side. Excellent, because it includes every number, including 6, but no more. Gloria, what about number 4? Open circle, closed circle? Open circle. And I'm just going to put the 4. And am I coloring in the left or the right side? The right side. Lastly, Matthew. Tasha can spend no more than $40 on new boots. So, what is your equation? B is less than 40. We are almost there. You're on the right track. We're almost there. What is it missing, Michelle?
I put x is less than or equal to 40.
Yes, less than or equal to because we see no more than. Can she spend $40? Yeah, she can. She just can't spend any more than. She can't spend any more than. So if I graph this, it's going to be a closed dot, and I'm going to be less than that 40. Your homework is page 621, numbers 1 through 7, And page 629, numbers 1 through 8.